Welcome to Get Your FRQ On. This is from the 2004 B exam. It's question 6, and it is not calculator active. In the question stem, we're given a power function x to the n and a line L, which is the tangent to the curve at the point 1, 1. In part A, we are asked to find the value of the definite integral from 0 to 1 of x to the n dx in terms of n. This is a pretty straightforward power function, so we can use the power rule for integrals here. If we use the power rule for integrals, the integral from 0 to 1 of x to the n dx is just 1 over n plus 1 times x to the n plus 1, evaluated between 1 and 0, which eventually is just going to simplify to 1 over n plus 1. So the value of that integral is 1 over n plus 1. In part B, we are told that the region T is the triangular region formed by the line L, the x-axis, and the vertical line x equals 1. And we are asked to show that the area of this region T is exactly 1 over 2n. Given how T is defined, the height of T is going to be 1 unit. In order to determine the base of T, we need to determine the x-intercept of that tangent line L. So the derivative of x to the n is just n times x to the n minus 1. And if we evaluate this derivative at the point 1, 1, we just get n. So the slope of that tangent line is just n. So the equation for this tangent line, if it goes through 1, 1 and has slope n, would be y minus 1 equals n times x minus 1. And we need to know its x-intercept. So the x-intercept of that line, if we substitute y equals 0 in, we can determine that the x-intercept is 1 minus 1 over n. All right, so this implies that the base of that triangular region T is 1 minus 1 over n. I'm sorry, 1 minus 1 minus 1 over n, which is just 1 over n. So the area of that triangular region, area of a triangle is 1/2 the base times the height. 1/2 times 1 times 1 over n gets us 1 over 2n. In part C, we're told that S is the region bounded by the graph of y equals x to the n, the x-axis, and that tangent line L. Find the area of S in terms of n, and then determine which value of n maximizes the area of S. So the area of that region S is going to be the integral from 0 to 1 of x to the n dx minus the area of that triangular region. All right, well, we just calculated both of those. The integral from 0 to 1 of x to the n dx is 1 over n plus 1, and the area of that triangular region is 1 over 2n. So the area of that region S is 1 over n plus 1 minus 1 over 2n. Since that is the area of that triangular region S, the rate of change of that region S with respect to n is going to be negative 1 over n plus 1 squared plus 1 over 2n squared. And that area is going to be maximized for some value of n for which dA sub s dn is equal to 0. Well, if that's going to equal 0, that would imply that 2n squared is equal to n plus 1 squared. If we rewrite that, we can come up with a quadratic function. And then we can solve that quadratic function. We get n squared minus 2n minus 1 equals 0. That is not factorable, so we can use the quadratic formula on this. The solutions to n squared minus 2n minus 1 equals 0 are eventually 1 plus or minus the square root of 2. However, in the question stem, we're told that n is strictly greater than 1, so the only value of n for which the area of S can be maximized is n equals 1 plus the square root of 2.